Today we're going to look at how to solve for coefficients of friction. In this problem, I have a block being pushed across a rough table. The block has a mass of 2.2 kilograms and it's being pushed this direction. In the first instance, the force that is being applied to the block is 10 newtons and the block does not start to slide. Since we know the block isn't moving, we can draw a free body diagram for the scenario. In this scenario, I have four forces. I have the weight acting downward on the block, I have the normal force acting upward out of this table, I have the applied force going to the right, and I have the friction force going to the left. Since the block isn't moving, I know that all of the forces add up to 0. I also know that the equation for friction, the force of friction, is equal to the coefficient of friction times the normal force. Since I'm dealing with a block that's not moving, the type of friction that I'm dealing with is static friction. So I have a coefficient of static friction, a force of static friction, and a normal force. Let's analyze our forces to see if we can figure out this coefficient of friction. I've analyzed my forces. The sum of the forces in the x direction are the applied force minus friction is equal to 0. And in the y direction, I have the normal force minus the weight equal to 0. I can use these equations to substitute information into this equation. I know that the force applied and the force of friction will be equal. If I add friction to each side, Fa equals F. I also know that the normal force and the weight will be equal. Let's take these values and plug them into this equation. Now I have an equation that I know more information in. I know the applied force is 10 newtons. I also know the object's mass. I can get the object's weight from its mass. Remembering that weight is equal to mass times the acceleration due to gravity. Anytime we're dealing with weight, this is the equation we can use. Let's plug it in here as well. And since I'm solving for mu, I'm going to divide both sides by mg. Mg cancels out on the right side of the equation. I'm left with mu. On the left side of the equation, I have the applied force divided by the weight. Let's plug in numbers and solve for our coefficient of friction. I have the applied force divided by the mass divided by g. Checking my units, I recognize that kilogram times meter per second squared is the same thing as a newton. So I have a newton divided by a newton. Those cancel out. You'll notice that there are no units in this. Mu is a unitless value. Now we can plug this into a calculator and solve for mu. Once we plug this into a calculator, we will get 0.46. In this scenario, the coefficient of friction is 0.46. Let's change up the scenario a little bit and see what we get now. In this new scenario, my applied force is 18 newtons. So I can go through the steps again. I do need to analyze forces. Again, my block is not moving. In the x direction, I have the applied force minus the friction. In the y direction, I have the weight minus the normal force. And since my block is not moving, my accelerations are all zero, which means my net force is zero. I need to remember my equation for friction. Friction is equal to mu times the normal force. Again, my block is not moving, so I'm still dealing with static friction. I'm dealing with the friction between two objects that are not moving relative to each other. And again, I indicate those with a subscript S. Looking at my forces, I see that since the block is not moving, my accelerations are zero. Since my acceleration is zero, my net force is zero. I can substitute using those equations in here. And I also remember that weight is equal to mg. I'm going to substitute in over here. I've substituted in the applied force and the weight. Now I need to substitute in mg for the weight and solve for mu. I solve for mu. I have the applied force divided by mg. Let's plug in numbers and solve for mu. In this case, mu is equal to 0.83. Let's look at one more scenario. In this case, our scenario, the box will be moving. So immediately after I applied 18 newtons of force, the block started to slide. The applied force changed to 15 newtons, and the block is now sliding at a constant velocity. This word right here, constant, means the velocity isn't changing. If the velocity is not changing, that means the acceleration has to be zero. Since the acceleration is zero, my net force is still zero. Let's analyze the forces, draw a free body diagram, and solve for the coefficient of friction for this scenario. Again, my forces all balance out because my acceleration is zero. I know friction is equal to mu times Fn. In this case, the block is moving, so we have a slightly different type of friction. We have a type of friction we call kinetic friction now. Kinetic friction is the friction between two objects that are sliding past each other. And it will have a different mu than the static. Again, we're going to do substitution and some algebra to solve for mu. I'm going to skip a few of the steps and just cut to the end. This is the equation we will wind up with. The kinetic coefficient of friction is equal to the applied force divided by the mass of the box divided by g. Let's plug in numbers and calculate the coefficient of kinetic friction. In this case, my coefficient of kinetic friction is 0.70. Hopefully this video has helped you work your way through some of the friction problems. If you have questions or still need help, feel free to reach out to me via email or through Schoology.